Hi everybody, welcome to Unit 2. Our second unit is going to cover angle properties, so we're going to focus in a lot on angles and all sorts of information about that. Our first lesson is actually combining the first two, that is 2.1 and 2.2. So we're going to talk about rays, angles, and angle measures. Alright, so starting with rays and angles. The definition is part of a line with one endpoint. The endpoint is called the initial point. The initial point always comes first in the name. When we name these, we put a single arrow on top of the name. And so there's a lot of really important information here. One bit of information is that C is a point. It's an endpoint. It stops there. But when we draw the arrow, that means it's going for infinity this way. Okay, so it's going to continue on this way. And so when we name it, we always start with the end point, and then we go towards the arrow. And so this name can be called a ray CD. That little marking above there tells us it's a ray. Now, even if it's pointing to the left, we're still going to start at the end point and go towards the arrow. So this is ray XW, even though it looks kind of backwards because it's starting at that point and going that way. When we have a ray that has several points on them, we can use any one of those points to name it. But we always have to start with the end point. So we always have to start with P, and then we can say, okay, well, this is PC, or we could call it PJ, because both of those rays, whatever ray it is, starts at P and goes on for infinity. So as long as it's going that way, we could call it either one. All right, when we read these names, we have to be really careful with what's up above it. So this has a single arrow up above it. So this is ray EF that we're talking about. And it's asking us for another name for ray EF. Well, whatever name we come up with has to start with E. If this ray starts with E, then we have to start with E, and then we're going to go this way. And the only thing it's going to pass through, the other one, is J. So this would be ray EJ, and ray EF are the same thing. All right, well, what about this next question? Are EJ and JE the same ray? So here's EJ, here's JE. Are those the same ray? They're not. They overlap each other, but they point different directions. So if I was going to draw this out, I could say, well, like ray EJ is here, but ray JE goes this way. Now they're going to overlap each other, but they're different directions, and this one's going to keep on going this way, and this one's going to keep on going this way. So they overlap, but they point different directions, so therefore they are not the same ray. All right, let's look at a similar question. Are EJ and EF the same ray? So here we have EJ, and here we have EF. Those are the same ray because they have the same endpoint of E, and then they go off towards this direction, and they go for infinity. So it doesn't matter if we call it EF or EJ, they both go on for infinity that way. So they are the same. We also have a thing called opposite rays. And opposite rays are two rays with the same initial point, but going in opposite direction. So they have to have the same starting point, but go in different ways. So we could start here at A, and we could go this way, or we could start here at A, and we could go this way. Those are opposite rays. So AC and AB are opposite rays. They both start at A, then A has to come first. This one goes to the right, this one goes to the left. Let's look at some other examples. Are EJ and FJ opposite rays? Let's take a look. Here's EJ, here's FJ. Are those opposite? No, they do not have the same endpoint. Even if we didn't have a diagram, we could look here at their names. Their names don't start with the same letter. So those are not opposite rays. They don't have the same endpoint. Okay, how about JF right here and JE right here? Okay, well, remember what I said a second ago. Let's look at their name. Well, they both start with J. That's good. So that's here. Yeah, these are. They are because they have the same endpoint, but they go in opposite directions. Okay, how about HJ and HG? So going back to my comment a minute ago, just looking at the names, they do both start with H, so that's good. But let's take a look at where they are. We have HJ going here and HG going there. Are those opposite? No. They both start at H, so that's good, but they're going the same direction, so that means they are not opposite. Last question, how about JH and JF? Okay, this is an interesting question because we have JH going this way, JF going this way. They do both start with J, that's true, but look, they're not going opposite. They have to be like in a straight line opposite each other. That does not count, so no. They go different directions, but not opposite directions. They have to be totally opposite, so that did not count. Let's go to the next page. So now that we know what a ray is, an angle is when you put two rays together that have the same initial point and go in opposite, well not opposite, go in different directions. So here's my angle ABC, and here's the exterior, the outside, here's the interior, the inside. The sides of the angles are rays. We have ray BA and we have ray BC. And the vertex is the initial point of the two rays. This is the vertex, it's the pointy part. That is the initial point of the two rays. You can think of the vertex as being the corner. The vertex is the official word though. Okay, name the vertex and the sides. So we need to think of what's the vertex and what are the sides. Well, first of all, a vertex is always a point. It's the corner, it's the pointy part. It only has a single letter, that is F. What are the sides? The sides are always rays. So one of them is ray FE and the other one is ray FG. Those are the two sides, and that is the vertex. Okay, next one. Name the vertex and the sides of the largest angle. So we have several. I don't know if you can tell. We've got one angle here, and then the bigger one. So it says the largest angle. That's what I want to stick with. The vertex is Q. It's just a single point. The sides are two rays. They both start at Q, and they go in different directions. So ray QP and ray QS are the rays that make up the sides of this angle. We always put arrows up above them. When we name angles, there are a couple different ways to do it. Let's start with the bottom ones because they are the easiest. This angle, there's only one letter there, so we're going to call it angle G. I still need to put my angle in front of it. This one, the only thing I have there is a 5. I need to put my angle in front of it, but this is angle 5. This one, there are several different options. With it, you really have to be careful. The vertex must be in the middle. You have to go in order, and when I say go in order, I mean the vertex has to be in the middle. So we could call this angle ABC because I'm going in order. Like if I drew this, I would go ABC. But if I drew it, I could also go the other way. I could call it angle CBA. Either one of those is okay as long as the B is in the middle. Now keep in mind, one thing here is that method 3 can only be used if only one angle has that vertex. We will look at some examples of what that even means. So let's just look at some examples. Okay, we have an angle here. There are a couple different ways we could call it. We could call it angle 3. That would be easy. We could call it angle D. That's another easy way. And there's two other ways. In both of the other ways I'm thinking of, the D is going to go in the middle. So CDE or EDC. Those are my two options. The D has to go in the middle. Similar here. Take a second and see if you can name these. All right, our options are angle F, angle 4, angle EFG, or GFE. The middle letter has to be the vertex. All right, on this one, the only names that we have are angle 1 and angle 2. We don't even have any other names. There is a third angle, and it's this one, but there's no way to name it because we don't have enough letters and stuff. So it's just angle 1 and angle 2. On this one, again, we have three different ones. We have this angle, we have this angle, and then we have the whole angle. And this is one I said a minute ago that I'm going to show you an example where it doesn't work. I cannot call this angle P. Why not? Well, if I called it angle P, which one am I talking about? Am I talking about the top one? Am I talking about the bottom one? Or am I talking about the whole thing? So you cannot say angle P. It's not specific enough. All right, but what we could say is angle XPW, or we could go the other way, angle WPX. Those two go together. Or angle WPJ, or angle JPW. And then the outside one is XPJ or angle JPX. So those are my options. Each angle has two different options, and there are three angles altogether.